Hello everyone, welcome to the third pre-recorded problem set. For this one we're going to be looking over the chapter material from chapter 4, which talks about vectors. And essentially everything that you need to know about this chapter may be able to be summarized with this first slide. So essentially all a vector is a line on the x and y coordinate planes. So where the x coordinate is represented by this I hat component, so the x component is represented by I hat, and the y component is represented by j hat. So a vector is essentially a line and can be represented in two different forms, the rectangular form and the polar form. The rectangular form represents our vector v hat, as a x component and a y component, a magnitude of an x component and a magnitude of a y component. Those magnitudes are represented by a and b. It can then be represented in a polar form where it has just a magnitude and an angle. Now in order to transition between rectangular form and polar form, we would use these two steps. So for rectangular form, if given the rectangular form and we want to find the polar form, we have to find the magnitude. That magnitude is v. Now v is equal to the square root of each component, the x and y components squared. So a squared plus b squared. And in order to find the angle, what we need to do is take the inverse tangent of b over a, of the y component over the x component. Now if we have the polar form, or this value right here, and we want to transition to the rectangular form, what we need to do is find our x component and our y component. In order to do this, what we're going to do is take v, or the magnitude, which is essentially the length of this line, and then we multiply it by the cosine of alpha. Now this makes sense because we can remember from the previous chapter on trigonometry that if we wanted to find this side, what we want to do is take the cosine of alpha, and we have, so if we want to find the x component, or this side, I'm sorry, what we're going to do is we're going to take the invert, or we have the cosine of that angle is equal to a over h. And because we know v, in this case h is v, we would multiply v, so we have v times the cosine of alpha is equal to a, or the adjacent side. And the same goes for b, or the y component. So we derive that from trigonometry and right triangles. So for this video, I want to go over two different problems. I want to do 4.7 and 4.11. Let's first start with 4.7. So 4.7 gives us the following graph. It tells us to imagine that it is a one-link robot with a length of 15 and an orientation of negative 120 degrees. So we can think of negative 120, where before if we started from the origin, 120 would look something like this. Let me redraw this. Would look something like that, and this would be 120 degrees. Well, negative 120 is the opposite direction, so it looks like that. So this is what we have. We have an angle of negative 120 degree orientation and 15 meters in length. So we can already represent this in polar form, which is, if we go back to the following, we have v, or the length of v, at an angle alpha. So we can represent this now in polar form as 15 at an angle of negative 120 degrees. So we already taken care of that. Now, a harder part when it's in this form is finding the rectangular form. So let's look at the previous slide and we see, or the previous page, and we see if we have it in polar form and we want to go to rectangular form, we're going to follow these steps right here. And we want to find the x component first. So to find the x component, we are going to have a, or x, equal to 15, or the length of the vector, 15 times the cosine of negative 120 degrees. The answer to this is negative 7.5 centimeters. And this makes sense because this vector is in the third quadrant. This is the first quadrant, this is the second quadrant, third quadrant, and this is the fourth quadrant. So we know that in the third quadrant, both the x component and y component must both be negative. So we have negative 7.5 as the x component. Now if we want b, or the y component, we do the length of the vector multiplied by the sine of the angle, which is negative 120 degrees. This answer is negative 13 degrees, or negative 13 centimeters. I'm sorry, not degrees. So now we can rewrite this as the rectangular form is equal to minus 7.5 I hat minus 13 j hat. And this is the answer to question 4.7. Now let's move on to 4.11. It's similar to 4.7, except we kind of follow a reverse procedure. So we're given the following vector. Let me redraw this. And this vector is called P, vector P. We have a length P, and we're given the y and x component. So 2 is the y component, and negative 1.5 is the x component. And this angle that we're solving for is angle alpha. So if we go back to the first page, we have components of the rectangular form. So we could rewrite this now as P, vector P is equal to minus 1.5 I hat plus 2 j hat. And this is the rectangular form. Now we know this just from the graph alone because we're given the y component, we're given the x component. Now we want to find the polar form. So how do we do this? We'll go back to that first page, and we have rectangular coordinates, and we want to find the polar. We have the rectangular form, we want to find the polar form. So what are we going to do? We need to find an angle and a magnitude. Let's first start with the magnitude, which is equal to the square root of the x component squared plus the y component squared. So if we want to find P, the length P, this is equal to the square root of negative 1.5 squared plus 2 squared. The answer to this is equal to the square root, or is just equal to 2.5 centimeters. Now if we want to find the angle alpha is equal to the inverse tangent of the y component 2 over the x component negative 1.5. And we know this from the first slide right here. the b, which is the y component, over a, the x component. Now, by plugging this into our calculator, we get the following answer. I'm sorry, we have to then, in order to get this angle alpha, this is going to give us a negative degree because we have a negative value right here. So it's going to give us a negative angle, so we have to then add that to 180 degrees. The reason why we're adding it to 180 degrees is because this is in the second quadrant. So we have alpha is equal to 180 degrees plus the inverse tangent of 2 over 1.5. Don't worry about that. So this now equals 126.86 or 87 degrees. And so the polar form of this vector P is equal to this magnitude, 2.5, at an angle alpha, which is 126.87. So from this first slide, we were able to derive the two problems that were given, and using that first slide, you should be able to answer all of the problems in this section. Thank you. I hope you enjoyed this video.